Imagine you want to send a letter to your friend, but you only know their name, not their address. You'd need a way to look up their address using their name. That's precisely what DNS, or domain name system, does for the internet. In simple terms, DNS is like a giant phone book for the internet. It translates human-readable website names like google.com into numerical IP addresses that computers understand, such as 172.217.160.142. Without DNS, we'd have to memorize long, complicated IP addresses to access websites, which would make using the internet incredibly difficult. DNS makes navigating the internet seamless and user-friendly by allowing us to use familiar domain names instead of remembering complex numerical addresses. DNS is essential for the internet's functionality and our online experience. Here's why. First, DNS simplifies web browsing. Imagine trying to remember the IP address of every website you visit. DNS allows us to use easy-to-remember domain names, making web browsing much more convenient. Second, DNS ensures website availability. When you type a domain name, DNS quickly directs your request to the correct server hosting that website, ensuring you can access the content you need. Third, DNS supports various internet services. Beyond web browsing, DNS is crucial for email, file transfer, and other internet-based applications that rely on name resolution to function correctly. In essence, DNS is the glue that holds the internet together, providing a reliable and efficient system for translating names into addresses, making the internet accessible and user-friendly for everyone. Let's break down the process of how DNS works step by step first. When you type a website name into your browser, your computer sends a DNS request to a DNS resolver, usually operated by your internet service provider, or ISP. Second, the DNS resolver checks its cache, a temporary storage of recently accessed DNS records, to see if it already knows the IP address for the requested domain name. Third, if the resolver doesn't have the information, it contacts a root server, one of the top-level servers in the DNS hierarchy. Fourth, the root server doesn't know the exact IP address but knows which top-level domain or TLD server to ask next, such as .com or .org, and directs the resolver to it. Fifth, the TLD server then points the resolver to the authoritative name server for the specific domain name, which holds the actual IP address. Sixth, the resolver retrieves the IP address from the authoritative name server. Seventh, the resolver stores the IP address in its cache for future requests and sends it back to your computer. Finally, your computer uses the received IP address to connect directly to the web server hosting the website, and the web page loads in your browser. Let's illustrate the DNS process with an example. First, you want to visit www.example.com. Second, your computer sends a DNS request to your ISP's DNS resolver. Third, the resolver doesn't have the IP address cached, so it contacts a root server. Fourth, the root server directs the resolver to the .com TLD server. Fifth, the .com TLD server points the resolver to the authoritative name server, for example, .com. Sixth, the resolver retrieves the IP address for www.example.com from the authoritative server. Seventh, the resolver caches the IP address and sends it to your computer. Finally, your computer connects to the web server using the IP address and the website loads. This entire process happens in milliseconds, allowing for seamless web browsing experiences. Section 5. DNS records. The building blocks of DNS. DNS records are like entries in the DNS database, each containing specific information about a domain name. Here are some key DNS record types. A record maps a domain name to its corresponding IPv4 address. This is the most common type of DNS record. A record, similar to A records, but maps a domain name to its IPv6 address. CNAME record creates an alias for an existing domain name, pointing one domain name to another. MX record specifies the mail server responsible for handling email for a particular domain name. NS record identifies the authoritative name servers for a domain name. These records are crucial for DNS functionality, ensuring that domain names are correctly translated into IP addresses and other relevant information is readily available for various internet services. Section 6. DNS resolvers. Finding the right address. DNS resolvers are like DNS clients, responsible for initiating and processing DNS queries to find the IP addresses associated with domain names. They act as intermediaries between your computer and the complex DNS hierarchy, simplifying the process of accessing websites and other internet resources. Resolvers typically reside on your ISP's servers, but can also be configured on your local computer or network. They play a crucial role in ensuring smooth and efficient internet navigation by handling the behind-the-scenes work of DNS resolution. Section 7. DNS servers, the heart of the system. DNS servers are the backbone of the DNS system, responsible for storing and managing DNS records and responding to DNS queries from resolvers. There are different types of DNS servers. Root servers, the top-level servers in the DNS hierarchy, providing the initial point of contact for DNS resolvers. TLD servers, responsible for specific top-level domains such as .com, .net, or .org. Authoritative name servers store the DNS records for a specific domain name, providing the final and authoritative answer to DNS queries. These servers work together in a hierarchical and distributed manner, ensuring the reliability and efficiency of the DNS system and keeping the internet running smoothly. Section 8. DNS and Microsoft Server, a powerful partnership. Microsoft Windows. Server operating systems include a robust and feature-rich DNS server role, providing a centralized and efficient way to manage DNS for your network. With Windows DNS Server, you can host DNS zones, store and manage DNS records for your domain names, configure DNS resolvers, specify how your network resolves DNS queries, create and manage DNS records, easily add, edit, and delete various types of DNS records, and monitor DNS performance, track DNS query statistics, and troubleshoot potential issues. Integrating DNS with Microsoft Server enhances network management capabilities, providing centralized control over DNS settings and ensuring reliable name resolution for your network devices and users. Section 9. Configuring DNS on Windows Server. Setting up DNS on Windows Server is a straightforward process. First, install the DNS server role, navigate to Server Manager, add roles and features, and select the DNS server role. Second, create a new DNS zone. Open the DNS Manager console, right-click on Forward Lookup Zones, and select New Zone. Follow the wizard to create a new zone for your domain name. Third, add DNS records. Within the newly created zone, right-click and select New Host A or EDDA to add records for your devices or web servers. Lastly, configure DNS resolvers. In the network settings of your server or client machines, specify the IP address of your Windows DNS server as the preferred DNS server. By following these steps, you can easily configure DNS on your Windows server and centralize DNS management for your network. Section 10. Troubleshooting DNS issues. While DNS is generally reliable, issues can arise. Here are some common DNS problems and troubleshooting tips. For DNS resolution failures, check your network connectivity, ensure your DNS server is running correctly, and verify your DNS settings on client machines. If you encounter incorrect DNS records, review your DNS records for any typos or misconfigurations. Use the command line tool to test DNS resolution for specific records. In case of DNS server unavailability, ensure your DNS server is reachable and responding to requests. Check for any firewall rules that might be blocking DNS traffic. To address DNS cache poisoning, flush your DNS cache on your computer or DNS server to remove any potentially corrupted or outdated DNS records. By understanding common DNS problems and troubleshooting techniques, you can quickly resolve issues and ensure uninterrupted network connectivity. Section 11. DNS, the unsung hero of the Internet. DNS often works behind the scenes, but its importance in the modern internet infrastructure cannot be overstated. It's the unsung hero that enables us to connect to websites, send emails, and access countless internet-based services without ever having to deal with complex numerical IP addresses. Understanding DNS is crucial for anyone involved in networking or simply curious about how the internet works. By grasping the fundamental concepts of DNS, you gain valuable insights into the inner workings of the internet and appreciate the critical role this often overlooked technology plays in our daily lives.